This is yet another interesting problem from CodeChef's March long challenge. The question name is Interesting XOR. We are given an integer c. Let d be the smallest integer such that 2 to the power d is strictly greater than c. We'll understand this in a while clearly. So the next part of the question says that consider all pairs of non-negative integers a comma b such that a comma b are individually less than 2 to the power d and a XOR b is equal to c. We have to find the maximum value of a multiplied with b over all these pairs. So what does the question actually mean? So it says that you are given a number c. So let's just jump a little bit into the input and the output section. We are given a number 13 as the first input. So if this is c, the binary representation of 13 is 1101. So it's saying that 13, the number 13, we have to find two other numbers a and b such that a XOR b becomes equal to c, and we'll also have to select such two a and b such that the product of a and b becomes maximum of all the possible values of a and b. So we can have actually a lot of values of a and b. Say since we are asked to maximize the problem, maximize the product a and b, so suppose let's look at this bit, the 0, where it is a 0. Now I know from XOR I know if it's a 0, I know that 1 XOR 1 is equals to 0. Now why did I select 1 XOR 1? I selected 1 XOR 1 because I'll have to maximize a and b. So if I have 1 and 1 in this bit, it would anyway maximize my a and b. The second challenge here is to find out all the other bits of a and b. Suppose say here this bit of c is 1. Now either any one of this bit of a and b can be 1. So here if a is 1, b has to be 0 such that a XOR b is equals to c. This particular bit, the ith bit. You can also choose values like if this is 1, you can choose here 0 and 1, works fine. If this is 1, you can choose 1 and 0. So there are multiple ways of selecting the individual bits. You'll have to find the maximum, you'll have to find such a and b such that a into b is maximum. Let's look at the constraints. Here the constraints are said that c is ranging till 10 to the power of 9, right? I'd like to share the details of how in this example test case 1 they have made 70 as the larger product of a and b. See here the number given c is equals to 13 and the binary representation is 1101. Now like I said, I'll have to choose a and b in such a way that the XOR of a and b, the XOR of a and b becomes c, XOR of a and b becomes c, and also a multiplied by b becomes maximum. Now see, XOR of a and b is equals to c, I can choose it in a lot of ways, but here there is two such values, that is 10 and 7. So the value of 10 is 1010 in binary and 7 is 0111. So if we see corresponding to each bit, 0 XOR 1 gives you 1, 1 XOR 1 gives you 0, 0 XOR 1 gives you 1, and 1 XOR 0 gives you 1. So it's fine, and a and b is the maximum product now, like 10 into 7 is equals to 70. This is the maximum. Now can there be any other possible solutions? Yes, but that won't be maximum. I'll show you another solution, but that's not the maximum one. See, if we just select here 1, here 0, and if we continue doing this, if here 1, here 0, see the condition a XOR b will always be satisfied. See, we choose 1 and 1, and here we choose again 1 and 0. Now see, 1111 is actually 15 and 0010 is 2. So 15 into 2 is 30. So see, this is not the maximum, yet this is satisfying the condition A XOR B is equals to C, but this is not the maximum case. So we'll have to find the maximum of A and B. Thank you so much. Now it's very easy for me to give you the solution of the required question, but I won't do so as it would violate the the regulations of CodeChef. We can discuss, but we cannot share codes or strategies. But all I'd say is, the question says is, you'll have to, without even calculating all the possible permutations of A and B, because the C, the number given is really long, like 10 to the power 9 is like a very big number. So for such a big number, if we are individually finding bits of particular blocks, then it is going to be really difficult, because that will be 2 to the power of 32 permutations, and it would cause an TLE to our solution. But can we find a optimized way to calculate the maximum of A and B? I'd ask you to think upon it, share the strategy, discuss it below in the comment section. I'd encourage you to solve the problem by your own, and we can, any doubts you can ask me in the comment section below. We can discuss well. Thank you so much.